Now it's time for segment proofs. So last class we did the algebraic proofs where we worked out algebra problems and gave our reasons as to why we did those steps. Today we're doing it similarly, but now we're doing it with a segment. So remember, every proof always starts with that given. It's right here. So we're going to fill in that first reason as given. Okay. Now it says DE is equal to EF. And if you see right above it, so from 1 to 2, it told us E is a midpoint, and I see E in both of these. So in that case, I just know they're applying the definition of a midpoint. Okay. Now, from step 2 to step 3, I notice that, yes, I have a DE still on this side, and I still have an EF on this side. But then I notice that they're adding DE to both sides. And when I'm adding the same thing to both sides of the equal sign, I'm using the addition property. Now I look from step 3 to step 4. I'm looking at the right side and I noticed they are identical, nothing changed. So I'm actually going to block them out for a second. And I'm going to look at the left side. I went from DE plus DE to 2DE. And we went over this with algebra proofs, and that is just combine like terms. Okay. Let's see, let's use a different color. Now from 4 to 5, I notice now I have DE plus EF equals DF. And if I look at the picture, I'll notice DE and EF makes DF. Small plus small equals big. That is the segment addition postulate. Okay, last one from 5 to 6. I look, and now I have 2DE equals DF. Again, the right sides have not changed, so I need to focus on the left. DE plus EF became 2DE. But if I look back to step 4, I know that 2DE is the same thing as DE plus EF. So when I trade something out for the same thing, I'm using the substitution property. Okay, pause here if you need to take a minute. If not, I'm going to move on to the second proof. Okay, proof number 2. Again, I'm looking at number 1, and it looks just like my given. So that is my reason. Number 1 is given. Then I look how 1 to 2 changes, and all that changed was these symbols. And if I look at my properties, I should remember that this is the definition of congruence. I'm going to abbreviate. Remember, I can interchange the congruence and equal sign because they pretty much mean the same thing. Okay, now I can say KL is the same thing as LM. And if I look at step number 2, both sets have something in common. They both have that LN in common. So they crossed out that LN. They didn't use the word and here, but this is the transitive property. Okay. and from 3 to 4. KL is the same thing as LM. If you look here, KL, LM, they're saying the same thing. So that's saying L has to be the midpoint. So that is the definition of midpoint. Again, pause here if you need to, but I'm going to move on to the next proof. Okie dokie. So, again, starting with my given. Then I look from 1 to 2. And just like that last proof, everything is the same except for my symbols. They change from a congruent sign to an equal sign. When the signs change, that is definition of congruence. Okay, now from 2 to 3, PQ plus QS is PS. I'm going to look at that picture. PQ plus QS is PS. And they're doing it for the other side as well. So again, when I'm saying that two smalls add together to make a big, I'm using the segment addition postulate. I'm out of space. I know I'm forgetting that E, but I'm sure you guys can squeeze it on your paper. Okay, so now they're saying TQ plus QS equals PS. So I'm going to look at this set right here. PS and PS stayed the same, QS and QS stayed the same, but PQ changed to TQ. So when things change, but here in number 2, if I know they're the same, and I interchange them, that is always the substitution property. Okay, now so from 4 to 5. Nothing quite changed from 4 to 5, but if I look from 3 to 5, because remember 3 had 2 parts to it, now I'm going to focus on this part and 5. So TQ and TQ stay the same, TU and TU stay the same, but notice this, QU and QS changed. And again in number 2, it said that those two things are equal to each other. So when I have two things equal to each other, they trade out for each other, I again have the substitution property. Okay, now I'm going to look at number 6. PS is the same thing as TU. Well, if we look at 4 and 5 as a whole, there's PS and TU together, and notice they have the same thing that they're equal to. So again, even though the word and's not used, I'm crossing out some common stuff because PS and TU equal the same thing, so that is transitive. Now we go from 6 to 7. Only thing that changed was the symbols. So when I change symbols, that is always definition of congruence. Okay, we filled out 3 proofs. Pause here if you need to, but I'm going to move to the next page. We have 3 more to go. So with these proofs, I'm going to have you guys do them a little differently. I'm only going to pre-fill part of the proof, and I want you guys to fill in the rest of it, okay? Call me over to check it, and I will let you know if we're heading on the same path or if there's some things that need to be fixed. So I'll put in number 6. Let's see here. I will do number 3. And actually, do I have a mistake? I already do have a mistake. Hello. I want to move this to number 2. I'm sorry, I put it in the wrong spot. I'm reading a little crooked here. And why not? Should I do one more? Yeah, I'll do number 5. Okay, so now you guys need to identify the reasons for 1, 3, 4, and 7. Pause here, and then when you're done, have me check it, and we'll let you know if you can move on to proof number 5. Okay, for proof number 5, I'm only going to put in 2 of the blanks this time, since I did 3 last time. And let's do number 2. And let's do number 6. Oh, yeah. It's the same thing, def of congruence. Okay, so again, I'm going to leave you 4 blanks. Go ahead and try those. Call me when you're done, and I will check it again, and you'll move on to your last proof. Okay, for the last proof, 7 blanks, so I will fill in 3 to leave you 4 to do. Okay, let's do definition of congruence again, why not? I'll do number 3. And I'll do number 5. Oh, running out of space. Okay, that's postulate. Okay, again, try this proof, call me over, I will check you off, and at this point, you'd be done with notes, and you can move on to your virtual assignment.